Today we're going to step away from guitar amps for a minute. We're going to use the frequency analyzer in this Fnirsi oscilloscope to check a low pass filter in a Eico 730 AM modulator we're working on. Quit chewing on that. Let's give Sheila something to do so she'll quit chewing on my tripod. Here. Maybe this will keep her busy for a little while. Okay, let's get back to our project. It was designed as a companion to the Eico 720 AM transmitter, which we'll be rebuilding it too. But this had two EL34s in push-pull, and it was rated for 50 watts. But the transformer had multi-taps in the back for the secondaries, I think all the way down to 600 ohms. It didn't go to 8 ohms because it didn't carry a speaker. It went right into a plate modulated a 61462 tube. But we're going to kind of just go through it for the first time and look and see what all we have. The first thing I noticed was one of the leads going to the choke was undone. After testing it, I realized it was open. Looking at the schematic, we can see that that choke formed a CLC low pass filter after the 6AL5 tube, which is a clipper circuit right there, and this low pass filter canceled the harmonics from that clipper. Another thing I noticed, C3 is supposed to be 0.025 microfarads, and they have parallel 3 capacitors, a 0.1, there's the original 0.025, and another one, yeah, it's 0.2 to get about 0.33 microfarads out of it. So they was trying to make the low end pass through easier. It's got a little magic tube in it to show you when you're over modulating. I think it might show the clipping level too. I don't know, I have to look more into that. All right, to set up this little experiment, we breadboarded this little section right here of the filter using my 7 Henry choke and changing the values out. That's where these little capacitor assortments come in handy for doing a little test like this. All right, we've got our circuit set up just like this with a 220K resistor to ground and our signal going in right here in channel 1 right here, monitoring our signal in. C4, we're going through a 0.1 capacitor, and we have the C5 to ground, 0.001. Instead of a 5 Henry choke, I had a 7 Henry. I don't have a 5 Henry, so we're going to see how it acts. And then we have this capacitor here and a 100K load resistor going to ground. And this is where our channel 2 point goes in at. We're going to run a scan and see what we get. This is our breadboard. There's channel 1 and our signal coming in. These are tied together. Ground and channel 2 right here on the output of the choke. Here's a view of it just zoomed out a little bit. Now in oscilloscope, you go to function and then go to frequency response analyzer. Then you set your start frequency to 10 Hertz and your stop frequency to 8 kilohertz. You can do a frequency count. I just did 20. You can see with this setup, the frequency starts to roll off about 1.5 kilohertz. And at 5 kilohertz, you're at negative 20 decibels. We really want to get this where it starts dropping off about 5 kilohertz, so we'll be in our bandwidth. So I went back to the breadboard and did some different values for C5 and C6 and ended up with 33 PF on each one of those. But I also had to raise the load resistor to 470K to get it down. And after running this plot, it looks a little better. And now at 5K, we're only down 4.5 decibels. Before we was down 20 decibels. But I think I'm gonna wait, and I've got a 5 Henry choke ordered. We'll wait till it comes in and run this experiment again, and maybe we won't have to change the load resistor and we can leave the rest of the circuit like it was. You can also use the oscilloscope using channels 1 and 2, just like it was set up. Channel 1's input, channel 2's a blue output, and use your signal generator inside the oscilloscope. Here we have it set at 10 Hertz. We have 313 millivolts RMS coming out with 351 millivolts going in. Now we can change the frequencies of the generator to 100 Hertz here. We have 356 millivolts going out with 359 millivolts coming in. You can see the waves are pretty equal. Just keep bumping the frequency up in your signal generator. Here's 1000 Hertz. See they're still pretty equal. And at 2000 Hertz we can see channel 2 coming up just a little bit. Notice your output is a little bit higher, 393 millivolts, than the input at 362 millivolts. And at 3 kilohertz, we can notice channel 2's shifting a little bit. Our input's still at 362 millivolts, but we're at 420 millivolts output. Then at 4 kilohertz, we see that it comes back down some. Got 362 millivolts in and 377 millivolts out. So it's resonant somewhere between 3 kilohertz and 4 kilohertz. Then at 5 kilohertz, we can see it starting to drop down now. And it continues to drop down from 6 kilohertz to 7 kilohertz to 10 kilohertz. Well, that's about it. I just wanted to do a quick demonstration of some things you could do with this meter, oscilloscope. I'm waiting on parts to come in, but I'm going to do a full build and go through everything with this amp. And we're going to build the AM transmitter too to go along with it. But I'm going to inject a signal with my Eico 7300 into the transmitter and bypass all the other circuitry. But we're going to go through all of that. So if you like this kind of stuff, you're interested in it, please like and subscribe. Leave me a comment if you have any questions or anything. And I appreciate you watching.